Alright class, so what we're going to look at today is graphing the sine curve. And today we're just going to focus on graphing the basic sine curve. And then the next few days we'll be looking at the transformations of the sine curve. So what we're going to do to graph the basic sine curve is we're going to complete a table of values. So here we're given different values of x, and then what we're going to do is we're going to substitute these x values into the x here, and then calculate it to get what the corresponding y value would be. Again, just like with the trigonometry unit, make sure that our calculator is set to degree mode. Again, the quick way to check is there should be a D or DEG at the very top, or if it doesn't show, just type in sine 90 and it should give you 1. Okay. All right, so sine 0, you get 0. Sine 30, 0.5. You keep going. Sine 60. And this one I'll just round it to 2 decimal place, so 0.x7. And then sine 90, we know that equals to 1. That's how we check it's in degree mode. Then we just keep going. Sine 120, 0.87. And you just keep going. Sine 150, 0.5. Sine 180, 0. Sine 210, negative 0.5. Sine 240, negative 0.87. Sine 270, negative 1. Sine 300, negative 0.87. Sine 330, negative 0.5. Sine of 360, 0. Okay, so we completed a table of values. Now we're going to graph our results, okay, on this graph here. Okay, it just says that the domain is from 0 to 360. So let's graph the points. This is just x, y. So the first point is 0, 0. Next point, 30, 0.5. 30, 0.5. And then is 60, 0.87. 60, 0.87. 91, 91. 120, 0.87. 120, 0.87. 150, 0.5. 150, 0.5. 180, 0. 180, 0. 210, negative 0.5. 210, negative 0.5. 240, negative 0.87. 240, negative 0.87. 270, negative 1. 300, negative 0.87. 330, negative 0.5. And 360, 0. Now we're going to do our best to connect all these points together to form a nice sine curve. And it's going to keep going on both ends. But we're just going to stop here because we're only graphing it at a domain of 0 to 360 degrees. Right, and that's your basic sine curve. And this is one full cycle or one complete pattern of the periodic function. Okay, so with this sine curve, it's going to go on forever and ever on both sides. It's just that with this question, we're only graphing it from 0 to 360 degrees as a domain. But this just shows one full cycle of the periodic function. Alright, so based on this basic sine curve that we just graphed, we're going to analyze it. So it asks us what's the max and the min value of y equals to sine x. For which x values do these occur? So the maximum value, or the highest point, is at 1. And it occurs when x is, so at this maximum value is 1, and at this value, x is at 90 degrees. The minimum value, or the lowest value, is -1. And it occurs when x is, so -1, x is 270 degrees. What is the domain and range of, let's just say, y equals to sine x? And the domain is given in the question. We just graphed it from 0 to 360. Okay, so look at the x values for the domain between 0 and 360. It includes all the real numbers in between. The range, we'll look at the y values, and we do see there's a restriction on the y values. Lowest it will go is -1, highest it will go is 1. So we'll say that the range is all the y values. It has to be between -1 and 1. It includes all the real numbers in between. Okay, number 5, what's the period and the amplitude of y equals to sine x? So again, from the last lesson, we know period is the length of one cycle. So in this case, cycle starts here. So we have one complete pattern or cycle shown on the graph. So the length of the cycle, we look at where it starts. It starts at 0. Where does it end? It ends at 360. Again, when we figure out the length, we're subtracting the x values. So ends at 360, starts at 0. So the period would be 360 minus 0. So it's just 360 degrees. And I should add the degrees here too. Because the x is in degrees. The amplitude, again, is half the distance between the max and min. So if we figure it out using the formula, it's max minus min divided by 2. Max, we know it's 1. Minimum is -1. 1 subtract -1, that's the same thing as 1 plus 1. 2 divided by 2 would be 1. So amplitude is 1. Again, we can also look at the graph to figure out the amplitude. Max is here, min is here. Half the distance from 0 to 1 is just 1. Okay, so amplitude is 1. What are the zeros of this graph? So for zeros, we're looking at, this is just another word for x-intercepts. So where does it intercept the x-axis? We have 3 points, 0, 180, and 360. So be 0, 180, and 360. Okay, so what we looked at today, we introduced sine curve. So what we did was we used a table of values to graph the basic sine curve. Okay, so again, this is one full cycle of a sine curve. And we analyzed the properties. So we took a look at the max and min, and when they occur, domain and range, the period, which is again the length of one cycle, we subtract the 2x values at the end of the cycle, and the amplitude, half the distance between the max and min, which got 1, and then we also stated the x-intercepts. Again, starting tomorrow, we'll be looking at the transformations of this basic sine curve. And that's the lesson for today.